Okay, in this section, we're going to introduce a new kind of function. We're going to talk about exponential functions. The goals, the usual goals, we're going to evaluate exponential functions. So we want to evaluate and graph exponential functions. We want to solve exponential functions. We'll also talk about the domain and range of an exponential function. Anytime you meet a new function, you shake its hand and say, hey, what's your domain? So let's start off with an example. Suppose it's 10 years from today, and you took my message to heart. You learned how to study, and I like to think I've helped you with that. I've helped you, half of being a good student is time management. And I hope I've taught you a little bit of study every day is the best way to go. Anyway, 10 years from now, you studied hard. You majored in, engineering or maybe computer science or something, or maybe cinema, right? and now you're rich because you worked hard and you built up a little nest egg and you bought a house over on the coast, and it's summertime. It's a Santa Ana. So it's like 90 degrees at the beach. Yeah, it's a very specific fantasy, right? And no, it's not a fantasy. If you work hard, you can become rich. Or the goal isn't to become rich, but I would measure success as having enough money to do what you want to do, right? You don't have to be super rich, but you've done well, and you have enough to buy a little place out on the beach, maybe overlooking the beach on the bluffs. You have a nice pool, hot outside. You decide to have a pool party. And like any good host, you put out some refreshments, maybe a little deli tray, right? But you put the little the netting over the deli tray so the flies don't get at the deli meat, because I hate that. Don't you hate that when the flies you're at a picnic or something, you're outside and the flies are on what you're about to eat? So you put the little net over that. And the idea is this: on one little piece of roast beef or turkey, I don't know why I'm making an orange outline, but here you go. One little piece of roast beef, there's one little bacterium. And that would be at time 0, which we would call 6 p.m. And no big deal, right? Your immune system can handle one little bacterium, no problem. Party goes on into the night. You have a good time, and you go to bed late at night. And you wake up at 2 o'clock the next day, 2 p.m. the next day. You go out to your patio, and the deli meat is still sitting there, and you're hungry. And the question is, do you eat the deli meat? Okay, well, the way I phrased it on the screen here, you can see I asked you at 2 o'clock the next day, that's when you wake up, how many bacteria will be on that piece of deli meat, or maybe multiple pieces, assuming that the bacterium splits once every hour. Now, under ideal conditions, it could actually reproduce faster than that, right? For the sake of keeping things simple, let's assume it splits once every hour. So let's make a table and see how many bacteria we'll have. And let's see if we can make a formula that'll tell us or give us the ability to predict how many bacteria will be on that piece of meat at 2 o'clock the next day. So time, T for time, and let's use N of T for the number of bacteria at time T. So N of T would be the number of bacteria at time T. So 6 o'clock, we're calling 6 o'clock time 0. And we know that there's one itsy bitsy little bacterium on that piece of meat at time 0. Okay, well, if it splits once every hour, at 7 o'clock, 1 hour later, how many will there be? Well, just split this guy. How many will there be? You can see that there's 2. And at 8 o'clock, 2 hours after time 0, how many will there be? 4, because the first guy will split and then the next guy will split. There'll be 4. And then 3 hours later, how many will there be? It doubles, right? So the first guy splits, the next guy splits, the next guy splits, the next guy splits. You can see that there's 8 there. I don't think we need that picture anymore, do we? It looks like every hour it's doing what? The number of bacteria is doubling. So after 4 hours, 16. So we could keep going. 2 o'clock the next day is how many hours later after 6 o'clock? Well, it's 4 hours short of 24 hours, right? So it's 20 hours later. But I don't want to go all the way. I don't want to go all the way up to 20 with this pattern, with this table I've created. So let's see if we can identify a pattern here. I think you could think of 2 as 2 to the 1 power. You could think of the 4 as 2 squared, the 8 as 2 cubed, the 16 as 2 to the 4th power. 2 times itself 4 times. So what's the pattern? Now the exponent matches the input exactly, doesn't it? The exponent matches the input. So can you come up with a formula then? The base is always 2. The base of the exponent is always 2. Can you come up with a formula then we can use to predict the number of bacteria at time? Let's say the input is t. What would the formula be for the output, for the number of bacteria at time t? Well, okay, but just for time t. If the input is t, we'll call t 20 in a minute. What would the general formula be? 2 to the t. And that's it. You just created your first exponential function. In other words, we're saying n of t is equal to 2 to the t. This is an exponential function. So what defines an exponential function? Well, basically, I'll be more specific in a minute, but basically in an exponential function, the unknown is in the exponent, and that's new. That's what's new. Okay, now let's use this function to predict the number of bacteria 20 hours later at 2 o'clock the next day. So that's time 20 hours. So that's n of 20, right? Would be 2 to the 20 power. All right, get your calculator out. We want to take 2 to the 20th power. So go 2, and then see this button over here? We call it the caret button. I don't know why, but we call it the caret button. And that little guy we push, and that means take it to the power. And then punch in 20, hit enter. Oh my, how many bacteria is that? 1,048,576. 1,048,576. Let me scoot over so it's in the screen of the video. 1,048,576 bacteria, right? You should always write down what it is you're measuring. So your immune system could probably handle 2 or 4 or 8 bacteria. I don't know. I'm not a doctor, but I'm thinking over 1 million bacteria, that might be a problem, right? So the moral of the story is what? Don't eat it. But for some reason, you can eat the pizza that's left out all night and it won't hurt you. I don't know why, right? Okay. So the point of this problem was to gross you out a little bit, but also to show you an exponential function. Your first exponential function is this guy. So let's talk about the definition then of a more generic exponential function.